Well, a couple more examples here, and I'm just going to run straight through these so that you guys can see how this has worked out. And let's just run through what would happen. Now, in this case, we've got two radicals again, and remember that the key principle here was that we have to isolate one of the radicals at a time. So it looks like probably the easiest thing to do would be to add the square root of 2x plus 6 to both sides. So I'm going to do that. So I will get, and I'll do this in my regular normal color, the square root of 2x minus 1 would have to equal 1 plus the square root of 2x plus 6. And so we would next have to undo the radical on the left-hand side by squaring both sides. Now remember, when we square both sides, that means right over here on the right, we're going to have to use our FOIL method. So we're going to get 2x minus 1 on the left. Right, we undo the radical there, but now we're going to have to take 1 plus the square root of the quantity 2x plus 6 times itself, which means that we're going to end up with an expression that contains another radical again. But that's okay. We can handle that kind of thing. Okay, so let's try it out. 2x minus 1. That will equal, by the FOIL method, 1 times 1 plus 1 times 2 square root of 2x plus 6 plus 1 times 2 square root of x plus 6. So that means we're going to have 2 square roots of 2x plus 6. Kind of skipping a middle step there. Now, if you want to pause the video and work this out for yourself so that you see that this is true, then you should. We take square root of 2x plus 6 times square root of 2x plus 6. So we're squaring the square root of 2x plus 6. That gives us 2x plus 6 is our last term right here. Now, if we simplify a little bit on the right, we're going to get 2x minus 1 is equal to 1 plus 6, so I'm going to make that 7, plus 2x, pardon, plus 2 times the square root of 2x plus 6. And there's probably nothing else I can do here, so I'm going to subtract 2x from both sides. So I'm going to subtract 2x from both sides here, and subtract 7 from both sides. Subtract 7 from both sides. So let's see what happens right here. Of course, we dump every term that's not in the radical on the right-hand side, so we get 2 times the square root of 2x plus 6, and we get 0 minus 7, so that's minus 8. And so if we divided both sides by 2 right here to get rid of the factor, we would get negative 4 is equal to the square root of 2x plus 6. Okay, anybody see a problem with this one? Oh, go ahead, raise your hands. Yeah, see, the problem here is that we've got a rule about that sort of thing happening. Anytime you take the square root of a real number over the set of real numbers, your result is always greater than or equal to 0. What's the problem here? Negative 4 is less than 0. So we will have to state for this particular equation that there is no solution, which is always possible. Okay, so, well, it looks like we went through a lot of work to get there, but, well, we do need to get there. So even if you could come up with no solution, you need to know. All right, let's try the next one right here. We've got 3 times the square root of x minus 2 equals 2 plus 2 is equal to x. So to isolate our radical, of course, we're going to do the same thing we did before, right? Take 3 times the square root of x minus 2 and set it equal to x minus 2 by subtracting 2 from both sides. Now we need to square both sides equally. So we square on the left and we square on the right. And sometimes those things don't quite come out the way that I want to with my lovely little pen here. Okay, and hopefully my screen will stop freezing up on me. Allow me to do this. Come on, screen. Okay, so now, getting back to my pen here, it's the quantity, x minus 2 squared. Okay, so we square both sides right here, and on the left, we're going to be squaring 3 to get 9, and we're going to be squaring the square root of x minus 2 to get the quantity x minus 2. So that's good. Okay. And on the right, we're going to be squaring the quantity x minus 2, and if you recognize that as being a perfect square trinomial form, we're going to get x squared minus 4x plus 4. So now on the left-hand side, I'm going to distribute. I'm going to get 9x minus 18 is equal to our quantity on the right, x squared minus 4x plus 4. Then I'm going to add 18 to both sides, and I'm going to subtract 9x. So if I do that, I'm going to get 0 on the left. Negative 4x minus 9x is going to be minus 13x. And negative 18 plus 18 plus 4, that's plus 22, will equal 0. Well, let's see what happens when we work that one out here. If we look at both sides of this particular equation here, looks like we're going to get 0 is equal to, let's see, what could we multiply to get 22 and adds up to 13? Well, yeah, sure, right? 2 and 11. And so we would get x minus 2 and x minus 11, which means that our two equation solutions should be x equals 2 and x equals 11. Do both of them work? Well, it is worth our time to check. So let's check 2. 3 times the quantity 2 minus 2 plus 2 should equal x, which is 2. And, well, yeah, right? 3 times the square root of 0 plus 2 does indeed equal 2, right? Because this guy right here, that's just 0, right? How about 11? Does that one work? Well, let's try it. 3 times the square root of 11 minus 2 added to 2 should equal 11. If this works out, well, let's try it. 3 times the square root of 9 plus 2. If this works out, this is 3 times 3, that's 9, plus 2. Well, yeah, that equals 11. Sure enough, right? We're good. And so, in fact, this is a kind of equation where we will have two solutions, if you can believe that. And so our solution is going to be x equals 2 and 11. And we can get no solutions or we can get two solutions, depending on the equation. Okay, a couple applications to finish this off in the next video.